Okay guys, welcome to my YouTube channel. In this video I will be teaching you on the combination circuit. So we'll be looking at a combination circuit. So what is a combination circuit? Basically, this is the circuit which consists of electrical components connected in series and the parallel circuit. For example, this circuit here consists of electrical components both in series and parallel connection. So for example, we have these two electrical bulbs here that are connected in parallel circuit. At the same time, these two electric bulbs are also connected in series with this electrical bulb. So for example, if we close the switch here, we'll see our electrical bulb giving out light. Alright, so such a circuit here actually is called a combination circuit. So let's go to the next. So here, for example, if we represent the electrical resistance offered by this bulb as R1 and the electrical resistance offered by this bulb as R2, and then the electrical resistance offered by this bulb as R3, and our electric cell here represented by the circuit symbol as that. So then also, let's say the values of the resistance here are provided, and also the values of the cell here is provided. So let's say these are the values provided: R1 2 ohms, R2 12 ohms, R3 6 ohms, and the cell itself has the voltage of 12 volts. So this becomes actually an examination question that came in 2017 GCE paper 1, like this one here. So as you can see in this examination question paper here, which was B8, question number 8, which reads figure B8.1 shows 3 resistors connected to a 12-volt battery. So we have 3 resistors here. We have the 2 ohm resistor, the 12 ohms resistor, and then the 6 ohm resistor. These connected in parallel, and this one connected in series with these 2 resistors that are connected in parallel. So all of these resistors are connected to the 12-volt battery. So the question says calculate the effective resistance between X and Y. So effective resistance is the same as the total resistance. So here they never labeled which points here because they forgot, they are also human beings. So the point was actually between between these 2 resistors in parallel. Then B says the current flowing in the battery. So calculate the current flowing in the battery. All right, so let's go to the next part. So next part, which is C, says we calculate the current flowing through the 6 ohm resistor. All right, so let's go ahead and start answering the question right away. So let's say this was point X and then this was point Y. So according to question A, which is saying calculate the effective resistance between X and Y, so they are asking us to calculate the total resistance of these resistors connected in parallel. So remember the previous lesson where we derived the formula for calculating the total resistance for resistors connected in parallel. If you never watched that one, you can click on the link which is appearing here so that you can watch that video. So in that video we said the total resistance is given by this formula. So this is the formula which we use to calculate the total resistance in parallel circuit. So this R represents the total resistance. This one will represent this resistor as resistor 1, or this one, then this one will represent resistor 2. It can be this one or this one, that does not matter. So what we are going to do right away is to start substituting. So what we are going to say is to say 1 over R is equal to, then we'll substitute, we'll say 1 over, then this one we are going to say R1, let's say this one as resistor 1, which is 6, plus then 1 over, let's say resistor 2 was this one here, all right, 12 volts. So say over 12, then we'll say 1 over R is equal to, this one becomes a mathematical expression consisting of addition of two fractions. So when you are adding two fractions like this, you have to look for a common denominator in which the denominators here can go without giving a remainder. In this case, 12 is a common denominator. So what we are going to say, we'll say over 12 as a common denominator, and say 6 into 12, 2 times 1, which will be 2, then plus drops here, then we'll say 12 into 12, 1 times 1, 1. Then we'll say 1 over R is equal to 2 plus 1, which will be 3 over the same 12 here. Then what we are going to do next is to make R the subject of the formula. So to do that, we are going to introduce a cross multiplication here, where we are going to say R times 3, which will be R3 equals then 1 times 12, which will be 12. So for us to remain with R alone here, we are going to divide by 3 on both sides of the equation. Then this 3 and 3 will cancel, will remain with R, then 3 into 12, which will be 4. So this means that our resistors here will be 4 ohms. So the total resistance between X and Y is actually what? 4. All right. So basically, this one can come back to a situation like this. So meaning we have added the total resistance here, which was in parallel, to before like this. Now it is in series with this one. All right. So then B says we calculate the current flowing in the battery. So they want us to calculate the current which is flowing through the battery. So remember, the current that is flowing through the battery is the same current flowing through the 2 ohm resistor, the same current flowing through this parallel actually circuit here. Though when it reaches here, some goes there, some goes there. But what we should keep in mind is that whatever is coming from this parallel circuit here is actually the same one which came here. The electric current which came on this side is the same one which will go out. So even when we add total here and come up with this, it means that the same current which passes through the 2 ohm resistor is the same current which passes through the 4 ohm resistor. So here, for us to be able to calculate the current flowing through the battery, we must be able to calculate the total resistance that is resisting that current. So total resistance and then total voltage will be able to help us to calculate the current. So for us to be able to calculate current in this circuit here, which has become like series circuit, we know the formula. Remember, in this video popping up here, we derived the formula for calculating total resistance in series. So if you didn't watch, you can click on the link here and then watch it. So we said total resistance, which is R, is equal to resistor 1 plus resistor 2. So in this case, we'll call this one resistor 1, this one resistor 2. So say R is equal to 2 ohms plus 4 ohms, which will be R is equal to 6 ohms. So meaning that the total resistance being offered in this circuit is 6 ohms. So we are now going to introduce Ohm's law, which says voltage is equal to current times resistance. So now we know the voltage which is provided, which is 12, and then we know the total resistance which is opposing the current. So we can make current the subject of the formula as current is equal to voltage over resistance. So we'll substitute to say current is equal to where there's voltage 12 divided by where there's R 6. Then we are going to say current is equal to 6 into 12, 2 amps. So our current here becomes 2 amps. So this means that the current which is flowing through the electric cell is 2 amps. So let's go to the next question. So the next question, which is C, is asking us to calculate the current flowing through the 6 ohm resistor. So this is the 6 ohm resistor here. So they want us the current flowing here. So when the current that we have calculated previously, which is actually 2 amps, when it comes like that, it passes through the 2 ohm resistor, and when it reaches a junction here, some current passes through the 12 ohm resistor and some current passes through the 6 ohm resistor, and when they come here they add and go back like that in a loop. So they want us to calculate the current that passes through here. When current 2 amps comes here, some goes here, so they want us to calculate that current which will go here. So for us to be able to calculate that current, we must understand first of all that we need to know the voltage across here, across these resistors in parallel. And remember, in our lesson on a parallel circuit and series circuit, so since this parallel arrangement is in series with these resistors, so the voltage across this resistor here and these two in parallel is different. So for us to be able to calculate that current here, we must also know the voltage across these resistors in parallel. And also remember that the voltage across resistors in parallel is the same. So you don't make a mistake by using this voltage, no, because this voltage here, it is further reduced, and also here, so it's not the same. So to assist us to calculate this one, or bring the previous resistors that we did, because we added the total resistors here like this. So when we add the total resistors here, we got what? 4 ohms. So since we got 4 ohms here, so that means that this is our total resistors in parallel. So it will enable us to calculate the voltage, since we know that the same current here which was passing and dividing here, it's the same current here which will pass and also pass here and go this way. So what we are doing is that the current that passes here together here is the 2 amps, but we don't know the one which went here. So but we need to know the voltage across here. So to help us to calculate the voltage across here is to use the total resistors, because that total resistors, if it is used to find the voltage here, then we'll know that it's the same voltage here, because these are in parallel, they're sharing the same voltage. So what we are going to do now, since we know the total resistor is here and the current passing through this resistor here total, then we'll use Ohm's law, which says voltage is equal to current times resistors, and then we know that current is 2 amps and the resistor here is 4. So we'll substitute, we'll say V is equal to 2, which is current passing here, times 4, which is this resistor here, which will give us 8 volts. So meaning the voltage across these two resistors in parallel is 8, as well as across these resistors. Now what we are going to do here is now to make for us to know what current now is going through this one, it is to use Ohm's law here and make current the subject of the formula here. So because we already know the voltage across here, so that voltage which is 8, so put it here and then we'll get the same resistor, put it here. So same our current is equal to 8 volt divided by 6. So this 8, which is volts here, 6 here, then which when we divide we'll get 1.3 amps. So 6 into 8 is equal to 1.33. So I decided to give this answer to 1 decimal place. Okay, so we'll say our current is 1.3 here. So now we are done, but I have a bonus question for us so that we can have more conceptual points or concept about this combination circuit. So a bonus question says calculate the voltage across resistor 2 ohm. So across this resistor 2 ohm, what will be the voltage there? So remember in our previous lesson, we said since this resistor and this they are in parallel, we can simply say the voltage, the total voltage of the circuit must be equal to the voltage here and the voltage here. So let's say total voltage must be equal to, or the voltage here and the voltage here must give us the total voltage in the cell. So voltage 1, which we are calling the voltage across the 2 ohm resistor, plus voltage 2, which is the voltage across the parallel, must give us equal to the total voltage. So we know that we calculated the voltage across here was what? Was 8, which was also here. And we know the total voltage is 12. So substitute to say V1 plus 8 is equal to 12, and then making collect like terms. So this one will cross this side, so have V is equal to 12 minus 8. So this crossed this side and it became negative. That's the algebraic law. Okay, so from here what we are going to do is to subtract, to say 12 minus 8, which will be 4 volts. So meaning our value is 4 volts. So this is the voltage across here. So we can prove, because the voltage across here was what? Was 8. 8 plus 4, 12. The total there. So we can also find it in this way using still Ohm's law. So we can say Ohm's law says the voltage is equal to current times resistance. We know current which is flowing through this resistor as 2, and then we know the resistor itself which is 2. So say voltage is equal to 2 times 2, which will be equal to 4 ohms. So 4 volts. So you have seen that we have proved we have solved this question using 2 formulas, and the answer is the same. So guys, if you have learned something in this video, please don't forget to give it a like, and also let me know in the comment section. As for now guys, bye and see you in my next lesson. Peace.